Hey class, it's Mr. Woodbury. We're moving on with our final review. I'm on problem 16 in our Zoom final review. This is a chi-square test of some sort. A company is studying the absence patterns of its workers. A sample of 362 absences showed the following results. At the 0.05 level of significance, test the claim that the proportion of absences is the same for each day of the week. Now, some students see this table of values and start to think, is this a contingency table? And is this a test for independence? Even though we do have column headers up at the top, we have 5 different categories at the top. There's only one category listed for the rows, and that's the number of absences. So it's not a contingency table. It has to have more than one row for that. Also, we're talking about the proportion of absences being the same for each day. So what we really have is a sample that's broken into 5 categories, and we want to see how well they fit claim percentages about those categories. This is a goodness of fit test. The null hypothesis is that the proportion for Monday is the same as the proportion for Tuesday, is the same as the proportion for Wednesday, is the same as the proportion for Thursday, is the same as the proportion for Friday. Now you could write 1, 2, 3, 4, 5 instead of those letters. I like to choose letters because they signify what we're working with a little better, but it's up to you. And we're saying that they're all equal here. So that means that each one is 1/5. There's 5 groups, 1 out of 5. But we also know that 1/5 is 20% or 0.20. H1, the alternate hypothesis here, it does not involve symbols at all. What we say is that at least one proportion is different than claimed. So we're saying that if we reject HO, we're going to be able to say that at least one of these is not 20%. It doesn't tell us that only one is wrong. It doesn't tell us which ones are too high or too low. It just tells us that they're not correct. The level of significance in this problem is 0.05. And again, goodness of fit is the test. Now for this test, there's no alternate test. If the expected frequencies are lower than 5 and it creates a problem, we can combine a couple of days together so that each expected frequency is 5 or more. Now, if you have some that are lower than 5, then you have to worry about the rest of the conditions. Are they all bigger than 1 and are less than a certain ratio smaller than 5? But here, this shouldn't be a problem at all. Right. So in StatCrunch, what I want to do is I want to take those 5 values and type them in one column. Next to those, I can type the percent that I was expecting to see. Then I can compute the test statistic and p-value. So let's switch over to StatCrunch. I've already typed those values in this column inside the Zoom final review data sheet where it says 16 day. Monday, Tuesday, Wednesday, Thursday, Friday. The absences are listed next to those. And again, this Zoom final review is inside your StatCrunch group, Woodbury Math 21. So the expected frequencies, I'm not going to worry about calculating. I'm going to let StatCrunch do those, but I can type in the expected percentages, which is 0.20 for each. When they're all the same, StatCrunch has a built-in feature for handling that as well, and I'll show you that. But I wanted to show you one place where I typed in those percentages in the column. All right, for the test, stats, goodness of fit, chi-square test. Observed are the sample frequencies, and those are in the absences column. Expected, I typed in the column I labeled as expected. And I'm going to see the expected frequencies automatically. So there's nothing else I need to do, just press compute. First, look at the column where it says expected. They're all 72.4. That means that they're all larger than 5 and the conditions for this test are met. If any of those are lower than 5, I have to analyze to make sure all the conditions are met. And if they're not, I can start combining columns, like I said. Okay, the chi-square test statistic is 4.77. And the p-value is 0.3119. Now, I did want to show you how we can compute this without typing in those 0.2s. So let's run through this again. This time, I'm only going to use the expected column. Stat, goodness of fit, chi-square test. The observed are still in the same place, absences. But for expected, I'll select this option, all cells in equal proportion. When I click compute, notice that the results are exactly the same as we had. Okay? So either way is okay here, but I wanted you to see an example where you had to type those percents, so that's why I did it. All right, let's get back to filling out the rest of this test. I wrote the test statistic, chi-square is 4.77. The p-value is 0.3119. Comparing that to the level of significance, it's larger than 0.05. So we fail to reject HO, and that means there is not sufficient evidence to support what H1 says, that at least one proportion is different than claimed. And in the goodness of fit test, that's what you'll always see in your conclusion. And actually, before I wrote any of the problem, I could have written everything in the conclusion except for the words is not, because I know that's what my conclusion is going to look like. Then whether I reject or fail to reject, I can fill that in. All right, so that's the goodness of fit test. We'll continue this final review by taking a look at the problems from chapter 13 in the next segment.